Okay, so hi, I'll be going through the advanced static analysis now, and so I'll go right on and open the IDAPro free, and new, I'll open the malware that we'll be analyzing today. So next, okay, so firstly I'll show you the graph of the malware. You can see there's a lot of subroutines here. Oh, sorry, subroutines here. But I'll go through the major ones detailedly soon. Okay, so I'll first go to over here. Let me close this down. Okay, so this is the start of the malware, and there's a lot of code here, but I'll focus on the call methods, and here they're calling to the sub 409b54, and we'll go right in. And the first thing we can see here is that this call get command line, and what this call get command line does is that it retrieves the command line string for the current process. And over here all the codes here is just trying to find the module name, and then over here they'll be getting the get module handler. That it means it's getting the handle of the module that they'll be finding up here, and it will return the handle of the module, and then it will call sub 40157f. And over here you can see that they are pushing in a library file name which has the value of icmp.dll. And what icmp.dll does is that it provides a functionality that allows developers to write internet ping application on Windows systems without WinSock support. So, and then there's load library A. So what they're trying to do here is they're trying to load the icmp.dll, and when it loads, it will return the handle. So they return to exa, and exa will then move to the value will be moved to ebp plus h module, and then the OR eax and eax, when they do this, and that icmp.dll it was a success, the loading of the icmp.dll was a success, it will not return a 0. Therefore, if it exists, we will go to this subroutine, which is 4015f1. And what it does here is that you can see these three functions: icmp create file, icmp close handler, icmp send echo. It all can be found in icmp.dll. And what they're doing here is they're getting the process address and storing it into their respective variables here, as you can see. And then following on, what they're doing here is they're trying to check whether these functions can be found by comparing the variable that the value was stored in, the process address that was stored in, with 0. So if icmp create file exists, it will not be 0, and it will continue on. But if it's not found, it will go straight to this function. So same thing happens for the icmp close handler, icmp send echo. And next you can see here they're pushing the offset of a kernel 32 DLL, which was the value of kernel 32.dll, and they're loading the kernel 32 DLL, which will return the handle, the module handle of kernel 32.dll to eax, and they'll do the same thing, which they will check whether it was a success. If it is, it will not return a 0. Therefore, it will continue on this. And this is the same thing. All this can be found in kernel 32.dll. And the same thing happens here is that they're getting the process address and storing it into their respective variables here. And what register service process does, it, as it says, it registers a service process. The create2 help 32 snapshot, what it does is that it will help take a snapshot of the current the specified processes as well as heaps, modules and threads used by these processes. And what process 32 first does is that it retrieves information about the first process encountered in the snapshot that's taken here, and process 32 next is the subsequent processes. So then continue on at log 4016C6. These 5 are the parameters for internet open, and the SX agent, the value will be Mozilla 4.0 compatible. So what internet open does is that it initializes an application, which is Mozilla 4.0 for this case. It allows it to be able to use the winnet function. So continuing on, you can see that this at log 4016E8 is loading the winnet DLL too. So if it's a success, they go to here, log 401708, and here internet get connected state. Remember during the basic static analysis we saw this string along with this string, and what this string does is that it's checking the state of the connection state of the local system. So following on, this one is getting the handle for the winnet.dll, module handle of the winnet.dll. Following on, the get module file name, what it is doing is that it retrieves the fully qualified path of the file that contains winnet.dll. Following on, see here they're comparing d40doco with 0. What is actually 40doco is actually the create 2 help 32 snapshot, the process address of this. So what it's doing is checking whether it has that function, and if it doesn't, it will go straight down to this 40188C. The subsequent ones are also checking the same thing for the process first and the process next too. And what this is doing is, and then it will then call d421218, which is the process 32 first. So sorry, before that they'll call 40doco, which is a snapshot. They're taking a snapshot of the current process and they are reading through the processes, the information about processes. So over here, you can see at 40188C, they're calling for these two parameters, LP, WSA data, and W version requested. Its parameters for WSA startup, and what it does, it initiates the use of WinSock DLL. So following on, at 4018E1, you can see pushing offset of a tskmgr_exe, which holds a value of tskmgr.exe. And remember, this string could be found during the basic static analysis, which was seen in the virus total, whereby the name of the malware was this. So over here, you can see that it's getting the system directory, and from this we can actually probably maybe know that the tskmgr.exe, the malware, can actually be found in the system directory. It means that it is probably a Trojan, as it's hiding in the system directory file, and so that the user may not think that it's malware. Instead, they would think that it's just a normal .exe file. And what it's doing here, str, is that comparing the existing file names in the system directory and checking whether there is a file called tskmgr.exe. If it does, it will continue with this line, but if it's not, it will continue on. It will state for a period of time, which here is 1000 decimal. And then over here, you can see here there's a file if exists, LP new file name, and the existing file name. So what they're trying to do here is that this is the new file name. They're trying to get if existing file name and overwriting it and creating an putting the malware and copying overwriting that file into this malware. That's what the copy file is doing. And proceeding on, what this whole chunk of code is trying to do, this part is where we can see that it's probably a worm malware also, because it is copying itself multiple times with different names into my downloads folder directory. So over here, they'll then start creating process A, and subsequently you will continue on with log 402095. And over here, what it's doing is creating registry entries, which is from software Microsoft Windows current version run, and then they're adding the value name to configuration loader. So these are where all the registry can be found, and what this registry probably going to do is that it will allow the malware to run every time the user logs in. So this is the persistency part of the malware. Following on, you can see many strings about ping, UDP, PRIVMs, SG, and what all this is the what they're trying to do, these strings are trying to do is to connect to bots.no-ip.com. They're trying to connect to this IRC channel, and in these codes, all these codes, what they're trying to do is trying to get establish a connection with it. And here, following on, scroll down, see over here they're trying to connect with it. So as you can see here, we'll go down from here, and it will call sub 4024E2. Let's try go in, and here, okay, continue on. We see host short HTONS, and then we see network-based indicators, which is get host by name and get host by address. So let's go down some more, and then we'll see there's a creation of threads and calling of sockets and connecting. So what this whole subroutine is trying to do, trying to connect to the IRC channel that we've seen before that. And once they have established a connection, you go to this subroutine, as you can see, connected to the string, going on, and then it will then return 4. So let's go back. Here, they return 4 to AXA. They'll compare 2, so it is not 0. So they will not continue on with this. So they go here. So continue on, they'll sleep for a period of time. And over here is the strings to connect to a bot, and you see there's a loop back to here. So it's forever trying to get a connection, establish a connection, and as it keeps looping, even after getting a connection, so this actually is everything that the malware does. If the connection is still unable to be connected, they'll close the socket and do a cleanup of the WSA, and yeah, that's about it for the malware. So the next presentation the next video will be about the reflection of the analysis and the conclusion. So thank you.